Hello, and welcome to this third screencast in our series on how to produce an animated game with Dolphin Smalltalk. If you remember, in the last video we left off having produced what effectively amounts to a visual component capable of displaying an airspace with animated planes within it. Now what I'd like to do in this session is to actually wrap up that component inside a full application and make it a bit more game-like. So without further ado, let's move on. The first thing I'd like to do is to actually export our work from the community edition of Dolphin, where we created the component last time, and I'd like to move it over into the professional edition. I'm doing this for no other reason than to show you some of the features that are in the professional edition. If you only have the free community version, then please feel free to carry on with that. So first of all, let's go and find our ATC game package, which we created last time. Here it is. And let's export that out onto disk so that we can re-import it into the professional version of Dolphin. So inside the package browser, right-click on ATC game, and let's say Save Package As. Let's go and find our professional version of Dolphin, and let's save the package out there. And that's all we need to do. Okay, we'll exit the community edition now, and let's start up Dolphin Professional. I'm choosing to use the 6.1 beta edition of Dolphin, but if you only have the 6.0 version, then that should do for you. Okay, the first thing to do is to introduce one of the new tools, which is the Dolphin Idea Space. Now, the Idea Space is a browser, a tabbed window capable of containing several browsers or development tools. It tends to avoid some of the screen clutter you get with the multiple windows in the free version. And we'll move straight on and open a system browser inside this Idea Space. The system browser is yet another new tool, which provides you with a package-based view of your project. If you remember, the class hierarchy browser shows you the hierarchy of classes inside the entire image, whereas this will refine your view down to just the packages you're working with. Now, I've actually shrunk this window down. Normally, the system browser is a 5-pane window with the packages here, the class list here, the protocols and categories here, the method list here, and the source down the bottom. But since we're working in a relatively small screen space due to this screencast, I've chosen to unpin the categories pane to let it slide away and give us a little bit more working area and simplify things a bit. If we want to take a look at the categories, we can simply hover over this tab and the categories pane pops out. So the first thing to do is to load in the ATC game package, which we've previously saved out. So I go to the packages pane here and right click and choose install package, and let's choose ATC game. And we've loaded that in, and we see we have a class list which includes the 4 classes that we created last time. Now, one of the things I want to do with this game now is I want to introduce the idea of cities inside the airspace between which the planes can fly. So we're going to need an ATC city class, which will basically have act as either a destination location or a departure location for the various planes. So let's go ahead and define that now. So I right click here in the class list and say create new class. And let's call that class ATC City. And we can descend that from object for the time being. Okay. And we're going to have, inside our city, we're going to need some instance variables. City will have a name, a location, and because I'm going to represent the cities as circles inside the the ATC view window, let's give them a radius. And this radius can vary depending on what might be the population of the city, for example. Okay. Now, let's define some accessor methods for those. So we can go use the class menu, create accessors, and we'll select all of them for the time being. And there we are, we have our accessor methods defined for us. Now, what we're going to need to do is we're going to need to add a bunch of these cities to our default ATC model. So let's go over to the ATC model class, and we'll add an instance variable called cities, which is going to contain a collection of these cities, departure and destination cities for the planes to fly between. So I'm going to add this cities instance variable, but one thing you should be aware of here is we're now changing a class which has actually been serialized into one of our views. If you remember, our ATC view had a default model, which was an ATC model. So because the serialization did not include the plane's instance variable, any views that have been saved out like that won't now correctly load. I can show you that by, if I go to ATC view here and try and edit the existing view that we've created, the default view, we should get a walkback. And there you are. So we get an end of stream walkback as the STL input filer tries to read an object which it doesn't understand. So I'll just terminate that and close this view composer and show you what we do about that. Basically, we have to create a new version identification for the ATC model class and instruct the serialization input filer on how to convert from an old instance into a new one. Now the way we do this is we go onto the class side of the class that we're converting, in this case ATC model, and we define a method called stb version. stb stands for Smalltalk binary, by the way. You'll find instructions on how to do this in the standard Dolphin help. So I'll go fairly quickly through this. Now the default version number is 0, so we're going to bump that by 1 and answer 1 to that here. And the next thing we need to do is provide a conversion method called stb convert from. And this is passed over a structure called an stb class format. And what we need to do here is, we'll just put a simple description in here. Okay, and so what this needs to do is to answer a new instance built from this old class format object. So I'm going to answer, sorry, we have to answer a block that's capable of building a new instance from this class format object. So here I'm going to answer a block which is passed a unit of data, and we're going to check to see if the version format is less than the version which we're modifying. So we're creating a converter for version 1. So if we've got a version number which is less than 1, then we need to perform this conversion. And the simple thing to do is to create a new instance. Let us create as ourselves a local variable called new instance. And we'll create a new instance using a basic new. So that will be a completely blank object of the right size. And we're going to copy over the old instance variables up to and including the plain instance variable. So I'm going to use instvar output to copy over the old instance variables. Okay, and then I'm going to actually just fill in the final instance variable with what we require for our cities. Let's create an accessor method called setCities. Usually, if I want the access to be private, then I'll prefix it with the word set. And I'm going to create a list model on an empty ordered collection. Now we'll come back in a minute to see why I'm using a list model rather than just a straightforward ordered collection. I'll explain that shortly. Okay. And the final thing is to return the new instance from that block. So if we compile that, okay, we haven't got selector set cities defined as yet, so let's go onto the instance side and create that. There we go. And now, if we try and load in our ATC view, which we created previously, we should find that this will work correctly, although it doesn't seem to have done it in this particular case. It's possible that we defined the wrong version number previously. Let me just increase that version number up to 2, and similarly here. That's more like it. So now if I edit that, that loads in okay. Now that's don't worry about that, bumping that number up to 2. That's because I previously had a version of that object in my image. So you wouldn't have that case, and you should be able to use the version number of 1. Okay, I'm going to close down this View Composer window, and we can move on and try and populate the ATC model with a number of different cities. In order to do that, I'm going to modify the initialize method here. Now that conversion that we did to fill in the cities instance variable with a list model, a blank list model, won't actually be run during the initialization phase of new models. So we need to actually make sure we initialize our cities here. And we're going to, once again, use a list model on an empty ordered collection. And in fact, what I want to do is I also want to use a list model for the planes instance variable as well. Okay, now the reason I'm using list models here rather than just plain ordered collections is because when we come to build our composite game, I want to be able to receive notifications from the ATC model when planes are added to the collection, and a list model is a way of doing this. So basically we should be able to attach our planes list model directly to a list box on the screen, for example, and get a list of the existing planes that the model is controlling. You'll see how that works later on. So we've now initialized our collections to be empty collections, and let's now initialize our cities. Okay, obviously this method doesn't yet exist, and what we can do is we can do a bit of programming in the debugger here. Let me create a workspace inside our idea space, and let's create ourselves a new ATC model. And we'll evaluate that. Okay, and as we expect, we don't yet have an initialize cities method. Go to the debugger, and we'll implement that in ATC model. So let's add some cities into our model. I'm going to add Let's say a city for London, say. I'm going to add a city for Paris. Frankfurt. Madrid. And what else can we have? Let's have Athens as well. Okay, let's compile that and let's let it run. Okay, as we might expect, the ATC City class does not understand London, so let's implement that inside. Hang on, let me just start that again. Hang on. Okay, so we're implementing the London method, and what we're going to do here is we're going to call a constructor for ATC City, and we can answer self name London. We'll give it a, we need to have a location where it's going to appear inside the airspace map. Let's call that 50 at 50, for example, and let's give it a radius, also say 50, and let's let that run. Okay, as we haven't yet decided to define this this constructor method, let's do that. Name, location, radius. We'll implement that inside the city class, and we'll answer super new, and we'll pass over setting of these things. I'll copy that, paste it in here. Another quite good thing we can do with Dolphin is to change these parameters using the refactoring browser. So if we want to change that parameter, we can just use F2 to alter the name of this. We can call it, instead of that, we can call it a string name. And the good thing about the refactoring is that it changes all uses of the parameter name as well as the actual definition of the parameter. So let's go and do that here with a point location. And similarly here, once again, I'm pressing F2 again. Okay, now let's let that run. And on the instance side, we'll implement this set name location radius method. And in this case, we want name, a string name, location, point, and similarly the radius and we can compile, we can use the refactoring engine to change these again. F2, a string name, F2, point location, and F2 again. And you'll find there are a number of very powerful refactorings you can do. This is one of the simplest. I'm just demonstrating that for you here, so you get some idea of what things you can do with the refactoring engine. And let's let that run. Okay, so we've defined our London city. Now let's go through and define the others. So we need to define a constructor for Paris. Okay, so now I've implemented all of those cities. If I just inspect the result of this, we should find, if we look at the instance variables, that we have a list of cities, an ATC city here named London, an ATC city here named Paris, and similarly Frankfurt, Madrid, and Athens. And if I look at the code for that, you'll see we actually now have, in ATC city, we have class methods for Athens, Frankfurt, London, Madrid, and Paris. Okay. Now, let's see what happens when we try and show our ATC presenter. If we go to our workspace and say ATC presenter show. Okay. Well, we've got a blank window because we haven't got any planes in our workspace, but we do have some cities, but they're not being drawn as yet. So what we need to do is we need to go and tell the ATC model to draw the cities. So let's go to our ATC model class, and if we look at on the instance side in the draw on code, you can see that we draw all of the planes, but we don't draw the as yet we don't draw the cities. So let's copy this line and let us change it slightly to say self cities. These draw on canvas. If I compile that, you'll notice the ATC model does not understand cities, so we'll implement that. Okay, and let that run. And ATC city does not understand draw on. That's because we haven't yet written the code on how to draw a city. So let's do that now. Let's go into the implement draw on in ATC city. One of the things I quite like to do actually when I'm doing the drawing, we didn't do it last time in the previous video, but is to save the state of the canvas before we start drawing and then restore it afterwards. A good reason to do this is because any of the fonts or whatever you install in the canvas during this drawing will be left behind unless you do that, and may interfere with other drawing that goes on in subsequent methods. So let's do that. Let's define a state local variable. And let's save the current state of the canvas. Sorry. Using the canvas's save method, and at the end we can restore that by using restore state. Now, the first thing we want to do here when drawing our cities is to draw a number of circles based on the radius of the city. So we'll change our canvas's brush and pen into a particular colour. Create a new brush. With the colour of the city, which we'll define shortly. Let's also create a pen with the same colour. Okay. And let's draw a circle, which we can do using the ellipse method of canvas, and we'll draw that inside the bounding box of the city, which we'll also define that method shortly. We're also going to want to include the city name centered in the middle of that circle. So we'll assign a font to the canvas, and we'll use the name pixel size creator. Let's use an Arial font with a pixel size of say 10, and we will draw that inside the circle using text at location, and we'll use the self location. And we're going to offset it slightly so that it actually centers up properly. So I'm going to just subtract half the font height off that. Okay. And if we now compile that and let this run, the ATC city does not understand colour. Let's implement that. One of the things that's quite useful to do here is if you want to be able to choose a colour for your in a method, it's sometimes useful to in a comment use the colour dialog, show modal, and then you can execute that by typing Control D. We can now then choose a colour for our cities here. So let's choose, for example, something like this yellow colour. We can then take that result of the dialog box and we can answer it from this method. Okay, that run. I'm going to now create the bounding box for the city, centered on the location of the city, and with an extent of the radius times 2. Okay, and now if we go back here, we see that we have in fact drawn some of the cities. We haven't got it quite right because the text needs to be centered horizontally as well as vertically, and also really we could do with actually setting a transparent background on that text too. If we want to do that, what we need to do is we need to be able to use some Windows constants. So I'm going to go to the class definition for ATC city, and I'm going to include in it the Win32 constants pool dictionary. And that will allow us to use some of the standard Win32 C++ defines inside our method. These are the defines which are normally used to set features of the device context. So let's go back into the draw on method for ATC city, and let's we want to center that that text. So before we actually draw the text, let's do set text align, and let's use TA_center. If you're a Windows program, you would have seen that before. Use that define. And similarly, we want to set a transparent background mode, and we're going to use transparent. Compile that and let it run. In fact, we've compiled that and it's run. So there we go. That looks pretty good. Okay, so now we've actually got the cities displaying in our presenter. Let's move on and let's try and build some of the other game components, the actual outside shell, which forms the heart of the game. So before we carry on, I think it would be worthwhile taking a look at an example of the sort of game window that we're trying to create. I'm intending to have a top-level shell view with a number of subcomponents within it. The main two subcomponents are the airspace window, which is the component we've created already, and this will have a number of flights flying to and from various cities, and the idea will be to steer those flights such that they don't collide with each other. On the left-hand side of that, I think we should have a list presenter showing a list of all the flights that are currently active. These can contain the flight identification number and their destination and departure cities. Because this is a game, we're going to need to have a score at the top, which will just be an integer score line, which will govern whether how well somebody's doing in the game. And to the left of that, let's have a rather large text field where we can display a status message such as warning or whatever whenever it looks like two planes are going to collide. Now at the top we've got we'll have a number of menus. The first will be a game menu to start and stop the main game. The second, I'm going to include a flight menu to be able to actually create individual flights. This will be mainly for testing, but it would also could be used as sort of practice mode. And also there's a course menu, where there will be a couple of commands for changing the course of the selected plane. And you'll be able to select planes by clicking on them in the air traffic control space, and also by clicking on them in the flight list. So let's move on, and let's first of all create our shell presenter that will be holding this main window. Right, so I'm going to need to create a subclass of shell, and let's call this, what have we got here? Okay, I'm going to create a subclass of shell called ATC game shell, and I'm going to descend that from the shell presenter class. Okay. And this will have a number of sub-presenters in it, which correspond to those views that we saw in that example. So first of all, we're going to have a presenter which displays the planes, and then we will also have this will be for the planes list, and then we also want an airspace presenter and a score presenter, which will contain something to display the numerical score, a text status presenter, and that for the moment will do. Let's compile those in, and let's now create, on the instance side of ATC game shell, let's create these components in these instance variables. So we're going to need a create components method. You always call the super class implementation create components, and we will set the planes presenter to be, add to that a list presenter. Let's call that planes. These names here are used to identify the views to which the presenters will attach in the view. So we'll have have to use these names when we come to design the associated view. We're going to have the airspace presenter, and this is going to be one of our ATC presenters that we have spent all our time creating so far, and we'll call this the airspace. The score presenter is going to be a number presenter. Right. And we'll call that score. And finally, the status presenter will be a text presenter. And we'll call this status. Now, one of the other methods which we have to define, which we defined before when we created our ATC presenter, if you remember, was the default model on the, and this is created. This is defined in a default model method on the class side. So we actually want to have an ATC model in there, and so let's just copy that default method across into our ATC game shell. Now, as the ATC game shell is being created, first of all, this create components method will be called to actually create the individual sub-presenters. And then, when the model is assigned to it, the model colon method will be called, and will be passed that ATC model. Now, first of all, we want to assign this ATC model into our airspace presenter. And so let's do that. So first of all, we'll call the superclass implementation again. Okay, and let's assign the ATC, so the airspace presenter model, and let's pass over this ATC model that we're being handed here. So this will allow us to display the model inside the ATC presenter that we have. But also we want to pass over the list of planes to our planes presenter. Now the planes presenter is what's called a list presenter, and that is capable of displaying a list model. Now if you remember, I changed the initialization of ATC model to create a list model for the planes instance variable, and similarly a list model for the cities instance variable. Now this means we can assign these this planes list model directly in to the planes presenter here. It's probably easier to show you than to explain it. So if we're going to pass over basically the model's planes list, and that will allow us to display the planes directly inside our game shell. Okay, that should do for the time being. Let's compile that, and now let's go ahead and create our shell view for this game shell. Now, if I right click here and say Views New, it's a default view, and we get a view composer up. Now we've currently got this view composer inside our idea space, which is normally a good thing to do, but in this particular case, because we're limited with space a bit, I'm going to break this out onto the desktop. So I can use this idea space menu here and say breakout tool to desktop, and this will allow me to just resize this a little bit to see a bit more of what's going on. Now the first thing I want to create here is a container to contain the list presenter and the airspace presenter. So let's go over here and click on the containers category and drag a container view over into this area here. Now I'm going to turn the border on for the time being, just so you can see what's happening, but I'll turn that back off again later. So of that container view, let's turn has border on. Okay, now inside here we want to have a list box, list presenter, and also one of our ATC views. So let's once again go over here, find the lists category, and choose the enhanced list component. This is one which will allow us to have columns and headers. So let's drag that across into here. Okay, just do a little bit of resizing. Don't have to resize it too carefully yet, because you'll see why in a minute. And similarly, we need to go and find one of our ATC views. Let's go to the miscellaneous category, which is where that will have been put by default, and let's look for the ATC presenter default view. Let's drag that across here. Okay, and just resize that a little bit. And once again, I'm going to turn bordering on here just so we can see it a bit better. Okay, so now we have these components here, but obviously what we really like is them to resize to fit their parent container. Now, the way to do that is to use the Dolphin layout managers. Now, what I want to be able to do is I think I also want to have a slider that goes down the middle of these two here. So not a slider, a splitter bar that goes down here, which allows you to resize the two views side by side in proportion. So I'm going to use what's called a proportional layout manager to do that. If you select the container and find its layout manager property, it's currently nil, double click that, and let's choose proportional layout. Okay, now instantly you see that the two views have resized to fit their parent, and if we look at them, you will see they have been given an arrangement property of each of 1. Now this arrangement property governs the proportions of which they occupy this space. So for example, if I change the arrangement of ATC view to 2, for example, you'll see that it now occupies twice as much space compared with the list view. I'll change that back just to make it easier to do the editing. Now I said I wanted to have a splitter bar, so let's go and find the splitter bars inside the toolbox. Splitters are here. Let's drag that horizontal vertical splitter and drop it inside this container. And you can see that it hasn't actually resized as yet. So what we need to do is to just, we need to just make sure that it's in the right place. Let's select the splitter, and let's use the arrange menu to bump it up into the right location. Now that splitter looks a little bit too wide to me, so let's not take the default width. Let's reduce that. The current default width is 9. Now it's using what's called the preferred extent. So if we uncheck preferred extent, make it false, we can now modify this and perhaps change that width down to say 5. There we go, or possibly even 4. That's better. Okay, so now we have our list box here and our airspace presenter here. Let's fill in the columns for our list box. And in order to do that, I will select the list and add 2 more columns to it. Let's resize these windows. Okay, and let's drill down into the first column and call that the flight ID. Drill down into the second column and make that the departure city. And drill down into the third column and set the header text for that to destination. Now, we're not actually specifying where these pieces of information come from as yet. We'll come back to do that later. Now, we also said we wanted to have an area at the top with the status message and also the score. So let's add that now. I shall move this component around, give it a little bit of extra space. So in order to do this, what I'm going to do is I'm going to create another container, outer level container, and I'm going to put this container inside it. So just so I know what I'm talking about, let's give this container a name. Give it a textual name of main game area. This isn't really used by the program code at all, it's just purely for us to identify things inside the view. And now let's drop another container into the view. There we go. And this container here we can call, oops, once again I'm going to turn the bordering on for this so we can see what's happening. This container here I'm going to call its text something like info and score. Inside this area we want to have a text field which represents the status message. So we'll go to text fields. We'll choose a static text view, drop it inside this area here. And we're also going to want to have another area for the score. So let's choose a number field. Present a default view, and oh sorry, let's have integer text here. That's what we've happened. Let's drop that inside there. Okay, with that, let's turn the bordering on, but the client edge off, so we can just so we can see it for the time being. Now, these two containers here, the info and score, and the main game area, they need to be aligned within the inside the shell. And once again, we can use a layout manager to do that. So let's go and select the top level shell and choose a layout manager for that. We're going to use a different layout manager this time. In this case, we're going to use a border layout. And this is, I find, one of the most useful layout managers. Let's choose border layout. And now we have to say how we want the subviews to be laid out inside there. So let's first of all, with the main game area, let's choose an arrangement for that. And the possibilities are north, south, east and west, and centered. So since this is the main part of the game, let's choose that to be centered. Okay, and now let's choose the info area, and let's choose how that's going to be aligned. And we're going to, let's say, align yourself to the north, the top end of the area. And so now you see this has all laid itself out rather nicely. We can drag that to centre it up a bit. And now we can go around and turn off some of the borders. So let's do that. I'll turn off the border here. And similarly turn off the border here. And the scores, turn off the border as well. Okay. Now, the next thing we need to do is we need to go and give these various views names so they can be linked up with the presenters inside the shell presenter we created. So, first of all, the list of planes has a name of planes. The ATC view is called airspace. The static text will be called status. And the text field here will be called score. Now, because these are read-only fields, let's make sure that the score is read-only. and similarly with the status field. Oh, that's read only by default because we chose it to be a static text area, so that's fine. And let's just add a bit of text in here, which is more likely to be useful. Okay, see how that will look. Now, you notice that this field here has the wrong background colour. So let's set that to be, let's say the background colour of this field to be nil, so that it inherits the background colour of the of its parent view. Currently it's set to colour default, which gives you the default window background colour set by the Windows control panel. But if I set this to nil, we should get that to inherit the right colour. And similarly, we probably want to have this part of the view here with a distinguishing background colour as well. So let's double click on its back colour and choose one of the grey colours. Let's give it a light grey. Okay. And finally, before we move on to actually test this out, let's put a caption in. Give the game a title. Okay. So before we leave the view composer, let's add the top level menus to this shell view, and we do this by going down to the menu bar property and double clicking that to bring up the menu editor. Now, as I mentioned before, we're going to have three top level menus: the game menu, the flight menu, and the course menu. So let's create the first one. First one is called Game. We add another menu after that, and we're going to call that Flight. And we add, by right-clicking, another menu after that, and call that Course. We don't need to give them symbolic names, because we're not going to be addressing these menu items directly from inside our program. Now, in the game menu, let's add a command for start game. And we give it a symbol, which is the name of the command we want to execute. You choose what you like for this, but I'm going to call it start game. Also, by prefixing these with an ampersand, you can choose which is the highlighted option in the menu. Okay, I'm going to add a command by right-clicking, add a command after that, and this is going to be called reset game. We want to reset and restart the game. I'm going to give that a command with a symbol of reset game. And finally, I'm going to add another command for quit. Oops, sorry. And the command for this is one that already exists in the MVP framework, and to quit a top level shell you send the exit command. So, okay. And we can insert some separators here. Select an item and add a separator after it. Select an item and add a separator. And similarly, let's now move on to the flight menu. The first menu option, let's use this to be able to create a new random flight. To be able to generate a flight at random and have it move from one city to another. Similarly, that command is new random flight. And another command after that can be, let's create a specific flight from London to Paris, say. London, Paris. London to Paris. and indeed we could create a number of create a number of other options to be able to go from all the different cities. I'll just create a few more here. Okay. So now let's finally go on to the course menu, and in here we're going to add a couple of commands to be able to turn the plane either left or right as part of the game operation. So let's just say turn left, and so we can operate this game from the keyboard. I'm going to add an accelerator key here, so I'm going to use Control L turning the plane to the left and Control R turn to the right. So I type Control L here, and similarly with turn right. And we'll do Control R here. Okay. And that should basically be enough to get us going with our menus. Once again, save that view, and let's go back to our idea space. Okay, and let's now create our game shell and see how it looks. Okay, so here we have our view, and we can see that we're displaying the cities inside our the right-hand component. All of the cities are in fact there, but because the view isn't quite large enough to display them, we're not seeing them all at the moment. When we get to play the final game, you'll be playing it on a screen which is rather bigger than this resolution I'm using for creating the screencast, so I think it should be okay. We also have our menus here. Most of the items are disabled in the menus because we haven't yet implemented the command methods. However, one of them is available, which is the quit method. If you remember, that sends the message exit to the shell, and if I can just demonstrate that in operation here, and you see that it does indeed quit the shell window. We can find out where that's implemented. If we go over to the class hierarchy view here, if we look in shell, you'll see that that message is indeed implemented here as closing the view. Okay, so let's bring back another one of those views, and let's implement one of these methods up here. Let's implement the London to Paris method, and we'll use it to create a new random flight flying from London to Paris. So I'm going to create a method here which should implement that command, London to Paris. Okay, and I'm going to actually ask that to create a new random flight from one city, London, EC City, London, to Paris, to ATC City, Paris. I'll compile that. Now obviously we haven't yet implemented this method, but what we can do is we can do some programming in the debugger again. We can go over here, choose flight London to Paris. Notice this is now enabled, and the debugger pops up saying it does not understand that command, so that's that method. So let's hit debug and implement that in ATC game shell. We'll change these two here, departure city to a destination city. And now what I want to do here is I'm going to choose a random airline code, and I'm going to choose a random, for the flight ID, I'm going to choose a random speed and create a plane that flies from that from the departure destination to the from the departure city to the destination city. Okay, so now we have the our new random flight method, which is creating as a random flight number from a bunch of airline codes, and it's going to create the flight to have a random speed. We need to define this new constructor method, which will create this plane for us. We'll do that in a moment. And we also need to define this random method for the to create the random number generator to do this. So let's do that. Let's let this run now. And as we might expect, ATC Game Shell does not understand random. So let's just implement that in Game Shell for the moment to answer a random number generator new. Okay, done that. And now let's go and implement this constructor method for ATC plane. Okay, let's change some of these parameters. Departure, destination, flight ID, and height. Okay, so we're going to create a plane here. And we'll use the old constructor method which we created last time. And we'll pass over the flight ID there. And the starting position is going to be the departure city location. And the velocity initially can be 0. We can set the plane's height to be the height that we've passed over. We can set the plane's heading to be the destination, and we're going to create a new method called heading from, which will compute the heading from one city to another. And we can also create that method to assign the speed at the same time. Let's set the departure city and the destination city of the plane. And we can answer that plane. Okay, let's let that run. ATC plane does not understand height, so let's implement that for us. Okay. So this is going to set the height part of the position to be equal to the existing position, as a 2D point, so stripping off the existing height and then tagging on the new height. Let's change that parameter using the refactoring engine again. Okay, and let that run. And now let's create the heading from method. Okay, so here's the final heading from method. There's a little bit of trigonometry here to compute the angle from one city to another. Let's let that run. And now we need to implement the heading speed method. Once again, a little bit of trigonometry is needed. Okay, and I'll leave that as an exercise for you to verify that this is all correct, and we'll let that run. We not understand departure city. Now we are going to have to actually add a couple of instance variables to ATC plane here for the departure cities and the destination cities. So let's actually just come out of this debugger and go and do that. So what we need to do is to go to ATC plane and add a couple of instance variables. Okay, and we'll compile those in. Now, previously when we added a couple of instance variables, we had to go and modify the STB loader version number, but we haven't actually got any planes saved out anywhere using the serialization code because all the existing ATC models are empty, so we don't need to write any conversion code as yet. So let's now go and try this method again to create the random flight from London to Paris. And we're now in departure city, which we implemented before but didn't quite do it. And we can now set departure city is equal to LATC city and let that run. Similarly, destination city needs to be defined and let that run. And now you see we have a plane flying from London to Paris. Although at the moment it won't know that it's reached Paris, and it will carry on flying beyond there. Okay, so the next thing to do is to work out when we've reached our destination location, and then we can terminate our flight at that point. Now, I'm well aware that this video has gone on for quite some time, so I think this would be a suitable point at which to stop, and so we can all take a break. And we can carry on with the completion of the game in the final video in this series.